My name is Rambo Jacoby, everyone. I am a business development lead and a principal engineer in NVIDIA's Automotive data center team. Now, I think over the past couple of years, we've all heard a lot about how generative AI is affecting consumers. When you think of ChatGPT, when you think of Microsoft Copilot, when you think of Stable Fusion. But what I want to do for today's conversation is I want to shift it a little bit and talk about how generative AI and machine learning is affecting enterprises. Specifically, I want to focus on how these technologies are helping automotive companies, some of the largest automotive companies in the world, incorporate AI across all their workflows and make them much, much more effective. We're going to start off first by talking about how one of the largest automotive companies in the US, I bet you're not going to be able to guess who, is leveraging large language models across their entire workflow and making themselves much more effective and efficient. Then we're going to talk about Gen AI-enabled 3D pipelines and how it's helping companies design vehicles more easily and market them and create a much more compelling experience for their customers. Then we're going to shift to vision language models. I think this is really incredible. We're going to talk about how vision language models are helping with autonomous driving. This is really incredible stuff, and I'm going to do a very brief demo for you as well on it. Then we're going to shift the conversation to talk about the specific tools that NVIDIA and HPE provide to help democratize AI. These are foundation models. It's going to be NVIDIA NeMo, which is our framework for developing generative AI, and it's going to be NVIDIA Inference Microservices, also known as NIMs. And then I'm going to go ahead and invite my colleague Dan Sandman from HPE up onto the stage so he can tell you a little bit about the specific platform that NVIDIA and HPE are developing together to help automotive companies thrive with generative AI. So with that, let's go ahead and dive right in. Now, when most people think about Detroit Blue, right? When most people think about Ford, what they think about are American ingenuity. They think about amazing engineering. They think about wonderful manufacturing. But Ford is also now starting to make a name for themselves in industrial visualization. Ford is leveraging large language models and generative AI across almost all of their workflows, from helping increase the customer experience inside vehicles to helping make their data center and their call center representatives much more effective and efficient, to helping improve the experience that customers have when they pull into a service station. Let's start with the experience inside of the vehicle. One of the things that Ford is investing heavily in is developing large language models so customers can more easily interact with their vehicles, not through buttons, not through dials, but through their voice. One really interesting thing that they're focusing on is taking these really thick instruction manuals that come with all of our cars and converting that into a large language model by creating an LLM and connecting it to their database of information via RAGs, via retrieval augmented generative systems. What they're doing is they're helping their customers much more easily interact with a car. When they have a question about functionality, when something goes wrong, instead of having to look through a manual, instead of having to Google the answer, what they can do is they can simply ask the car, and that LLM will retrieve the data from the instruction manual and present it back to the driver in a very natural way. Wonderful experience. The second thing that they're doing is they're implementing AI, machine learning, and generative AI in their call centers. This AI listens to the conversations that people have when they call their representatives. It listens to the online chats that they have, and it draws out insight. It understands what the customer is asking about. It understands their sentiment. And what it does is it takes all of this unstructured data that comes in conversation and structures it and puts it inside of structured databases so that engineers back in Detroit, management, executives can very easily query this database to get a better sense of what it is that their customers are thinking when they call support, when they call their representatives. So a wonderful way of increasing the efficiency of their call center employees. And then they're also incorporating AI into their service bays. Typically, when someone pulls into a service bay with their car, they describe the challenge that they're having to the associate that's helping them, to the technician that's helping them. And then the technician has to go off and do a bunch of research and try to figure out what the issue is. And then once they identify a potential issue, they have to put in a bunch of research to find out how to fix that issue. Well, Ford is making it such that the representative only has to speak to an LLM and describe what the challenge is that the customer is having, and the LLM very accurately provides them with a couple of options of what could be wrong with the car, along with step-by-step instructions for how to fix it. So now they're helping improve the experience that customers have when they go to a service station as well, when they go to a Ford service station. This is how Ford is leveraging LLMs and AI across the board. Very interesting, very exciting work that they're doing. The other area where generative AI is supporting automotive companies is through 3D-enabled Gen AI pipelines. What these pipelines are ways for designers to be able to very quickly visualize their concepts. Today, what happens is when an automotive designer develops a design for cars, they start off with a quick sketch of that design. And then they have to spend weeks and weeks converting that sketch into something that looks nearly like production, right? Something that they can share with their colleagues, something they can share with their management, so they can do design reviews. Well, with generative AI, what these designers are able to do is make some very quick sketches of a concept. And in a matter of seconds, this generative AI takes this sketch and converts it into a photorealistic image of what that sketch is going to look like in production. They can take that generative AI and apply different colors to that vehicle, apply different materials, put it in different backgrounds and environments. So what this does is it helps these designers much more quickly develop vehicles and go through design reviews, which is fantastic, which is absolutely fantastic. Now, one of the other areas that generative AI is helping, especially in the 3D pipeline area, is marketing. One of the trends that is taking place in the automotive industry is that car manufacturers are moving away from the dealership model. Instead of selling through dealerships, what they're doing is they're trying to do direct to customer. Tesla's doing this, obviously, and companies like Ford are also starting to engage with this. But what this facilitates is a need to have a method of being able to demonstrate the soul in the vehicle, to be able to demonstrate how beautiful that vehicle is to a customer just through a website, Well, today, that's done through what are called 2D product configurators. With a 2D product configurator, a car manufacturer takes a vehicle, they configure it in all the possible ways that it can be configured. And then they take thousands of pictures of that configuration from many different angles, and they put those pictures up on a rotating carousel, a static rotating carousel. That is not compelling. That is not a compelling experience. So what's happening is these manufacturers are transitioning to 3D product configurators. With a 3D product configurator, a digital twin of the vehicle is developed, and with that digital twin, you can place it on a website, and in real time, generate real images of what that vehicle looks like in different configurations, from different angles. You can take tours of the vehicle from the inside, you can take tours of the vehicle from the outside. And with generative AI, you can now take these models and place them in different environments. The customer can say, hey, show me my Ford Mach-E when it's sitting in my driveway. Show me that Ford Mach-E as it's driving down Pacific Coast Highway in California. That is a great experience. That is an immersive experience that customers can really benefit from and get a sense of what a vehicle is so that they can more easily buy it online. Now, the other area in marketing that generative AI is affecting is the development of assets for commercials. When you think of the type of work that an automotive manufacturer has to do to create a commercial, it's very expensive and it's very tedious. First, they have to send scouts to be able to find a road that they want to shoot the commercial in. Then they have to go out and get tons of permits to use that road. Then they have to hire stunt drivers. They have to hire crews. And then they have to shut the road down. And then they just have to pray that the weather cooperates with them on the day of the shoot. It's incredibly expensive, in the order of hundreds of millions of dollars. Well, with generative AI, all that goes away. This content that I'm showing here, this was all created inside of a data center. There was no physical shoot involved in this. This is not science fiction. There's a company called WPP, it's one of the largest marketing companies in the world, that is helping automotive companies do exactly this, develop commercials inside of a data center. We estimate this will save hundreds of millions of dollars for automotive manufacturers. It is an incredible technology, Let's shift the conversation now and talk about autonomous driving. Today, autonomous driving is done through something called ensemble of models. What that means is that you have dozens and dozens of AI models, each of these models specializing in a certain aspect of autonomous driving. There's models for being able to detect obstacles, models for calculating distances, models for calculating time to collision between objects, other models for being able to identify driving paths, other models for breaking down intersections, and traffic lights, and maps, and signs, and so on and so forth. And then these models are all tied together with hundreds of thousands of lines of C++ code. Here's the challenge though. This is not scalable. It is not scalable to train and maintain all of these AI models. And when you bring them all together with so much code, there is a lot of possibility to introduce bugs into that. Well, what's happening is the industry is transitioning away from AV 1.0 to something called AV 2.0. With AV 2.0, instead of having an ensemble of AIs, what customers are doing, what companies are doing, is they're transitioning to something called a vision language model. A vision language model is one massive model, very similar to a large language model, that is trained by watching millions and millions of hours of videos of driving. Now, in the same way that ChatGPT, in this example, is able to understand, is able to infer, is able to develop a concept of how to respond to people by going out and scouring tons of data from the internet. A vision language model is the same thing. After seeing these millions of hours of driving, it is able to understand how to drive a vehicle. It is able to understand how and what the laws of the road are. And it's able to take that concept and generalize it to scenarios that it has never seen before. So although it may have never seen a child walking out in front of a car, it can understand that, you know what, I'm supposed to stop if an obstacle is coming in my way. Okay? This is not science fiction. This is not science fiction. In fact, Tesla, just a couple of months ago, rolled out their vision language models. Any of you guys own Teslas? No? No Teslas? Well, up until about 4 months ago, Tesla was doing the ensemble of AI. And 4 months ago, they switched to vision language models, and it is amazing the type of performance that vision language model gives. It makes the AI, it makes the self-driving so much more natural. Now, what I want to do is I want to actually show you a demo of what a vision language model looks like and how it works. It's going to be a static demo, but I couldn't do it in this kind of environment. Now, I know this image looks terrifying. I know this image of a girl running into an intersection with a ball looks terrifying. Now, don't worry, NVIDIA did not photograph a child running into the street. We didn't. This is a synthetically generated image that we created with one of our foundation models. Now, what I did is I created a synthetically generated image. Oh, and by the way, we actually have a demo here in our booth where you can create these type of synthetic images, so you can try this for yourself. So what I did is I created the synthetic image, and I fed it into one of our foundation models, one of our general foundation models called NEVA 22B. This is an NVIDIA foundation model. And I asked it a very simple question. I said, what should the cars do? I'm not leading it in any way. Very simple question. What should the cars do? And I was amazed by the response that it gave me. The cars should be cautious and slow down as they approach the child playing with a ball in the street. The child is not paying attention to the cars. This is not an autonomous vehicle model. It is a general AI model, and it has the understanding to know what these cars should do as they're approaching a child. And think about it, it does not take much from taking this type of instruction, this type of response, and converting that into actuation, and converting that into steering wheel commands, into braking commands, into acceleration commands. This is how autonomous vehicles are going to transition from the state that they're in right now, which is something called L2+, to much higher levels of autonomy, L4. Amazing, amazing. Now, as we talk about AV 2.0 and generating synthetic data, one of the things that NVIDIA is investing heavily in is creating synthetic data for our own AV program. This data is all synthetic. We're able to create generative AI imagery that shows different driving scenarios, whether it be in the snow, whether it be in the rain, whether it be in fog. And then we're also able to create different camera perspectives. This is a view of the rear view camera, a view of the left turn camera, a view of the right camera. And we're able to generate this content. We're able to generate all this synthetic data in multiple modalities. Besides cameras, we can do this with radar and LiDAR as well. This is what helps autonomous vehicles scale. This is how we are able to create models that truly understand the world and can react and can properly drive in a whole slew of different environments. Okay, let's move on. We've talked about generative AI so far, but here's the challenge. AI is hard. AI is very challenging. And it often takes incredible amounts of resources for a company to create AI from scratch. They need lots of compute, they need lots of engineers who understand how to develop AI models. But what NVIDIA doing is, along with our partners over at HPE, we are democratizing AI. And here's how we're doing it. The first way we're doing it is through foundation models. I showed you a couple of those foundation models just a moment ago. I showed you a reasoning foundation model. I showed you an image generation foundation model. Our customers can take these foundation models, download it from builds.nvidia.com, and start using it in their applications right away. No work necessary. No work necessary. The AI is already developed and ready to go. Now, for customers that need a little bit of additional customization of that model to make it more specific to their application, NVIDIA has something called NVIDIA NeMo. This is our framework for developing and training generative AI. This framework has tools for being able to curate your training data. It has tools for being able to distribute training data across thousands of GPUs in a data center to be able to increase the speed of optimization and model development. It has model customization tools. And when these tools are all put into place and a model is developed and trained and optimized, NeMo also has tools for being able to accelerate the inference of that model when it's in a data center. It has tools for being able to create retrieval augmented generation, so you can take that large language model and point it to a database of a customer's existing knowledge and insights. And it also has tools for being able to develop guardrails to make sure that the responses that the model provides to a customer are appropriate, and to make sure that the questions that a customer asks the model are also appropriate. And this is all done on top of HPE's infrastructure. This is all done on top of HPE's infrastructure. The other thing that we provide to help democratize AI, as we call it, is NVIDIA Inference Microservices, or oftentimes called NIMs. What these NIMs are containers of models, either foundation models that you can download straight from NVIDIA, as well as models that you can optimize. It has all the tools for being able to accelerate the inference of that model, and all the tools for being able to very easily and quickly deploy it into a data center and run it on NVIDIA's GPUs. These all come packaged, and a customer can very quickly take these, run it onto a data center, and access it via standard APIs, and incorporate AI directly into their applications. It only takes a couple of minutes. It's astounding the thing that customers can do with things. This is how we are democratizing AI. This is how we are making it easy for companies all around the world, regardless of the resources that they have, to leverage the power of AI. Okay, what I want to do now is I want to introduce my colleague Dan Sandman from HPE to talk about the specific solution that we're offering with HPE.
Thank you very much, Rambo. So as Rambo pointed out, lots and lots of major use cases, all kinds of great things we can do within automotive. But he also touched on one other thing. Why isn't this everywhere, right? Why don't we have this running in every single part of our organization within automotive? And the answer is, he touched on this, it's difficult, right? It's traditionally been difficult. So what HPE and NVIDIA have done, as he pointed out just a minute ago, is we rolled our sleeves up about a year ago and we said, how do we make this easy? And every time we worked on this, we kept saying that we got to make this easier. So what we've announced and what we've built together is a unique solution that is completely plug and play, right? No one else can provide this. This is literally deploy, and you can start running your models in production, or also customize and fine-tune them as well. So what it's built on, we'll go through this very quickly, it's built on HPE ProLiant servers, running NVIDIA's latest and greatest GPUs. That can be L40S, it's going to be H100, it's going to be H200, it's going to be Grace Hopper. Support all of that. Also tying this in with NVIDIA's Spectrum X and NVIDIA's Bluefield 3 technologies. What is this? Well, this all works together to provide the fastest, most productive AI network in existence. It's Ethernet, and it provides 1.6 times the performance of traditional Ethernet for AI workloads. We then tie in our Greenlight for file storage, layer on the software that Rambo just pointed out. So that's HPE's AI software stack. NVIDIA AI Enterprise, NIMs, as Rambo just went through. helping to enable the pulling in the required data to train, training models, testing models, deploying models, pulling in your own documents through what we call RAG. And then on top of that, also layering on our services and our management platform to make this easy so you can do it with a couple clicks. What does this mean in the end? This means you plug one of these in, and we have different sizes, right? We can start as small as you need and go and scale as large as you need to an entire enterprise. What does this mean? This means within 2 days of plugging this in, we will have your entire Gen AI infrastructure and your entire environment deployed and ready to deploy AI models. So we're extremely excited about this. Thank you to NVIDIA for this fabulous partnership, and we're extremely excited to work with you all. Thanks, Rambo.
Thank you, Dan. These are the types of partnerships that NVIDIA is engaging in to help, again, democratize AI. So wrapping this up, there's 3 points that I want you to take away from this conversation. First is that generative AI changes the automotive industry. It affects almost all of their workflows, from vehicle development to improving customer services and experiences and developing stunning marketing collateral that helps engage customers as well as reduce the overall cost that these automotive companies spend on marketing and marketing. Second is that for companies that want to leverage AI, they don't have to have incredible amounts of resources. They can leverage NVIDIA's foundation models to be able to deploy AI right away with very little work. And for those that want a little bit of customization, they can leverage NVIDIA NeMo framework to be able to modify those models to their specific workloads. And then third, for being able to deploy that model, for being able to very quickly leverage AI and incorporate it into their applications, customers can use NVIDIA Inference microservices to lower their time to money, to get their AI into production quickly and start leveraging all the benefits of that AI. All right, everyone, Dan and I will make myself available for a couple of minutes to answer any questions that you might have. Thank you so much for joining.